In this video, we'll systematically go through figuring out the lengths of the sides of a 30-degree, 60-degree, 90-degree triangle. There are two principles that are going to be in play here, and they work like this. So if the three angles of a triangle are given, but none of the sides, then you're allowed to pick one. The key thing is you can pick one, but not two and not all three side lengths of the triangle. So the remaining two sides, once you've picked one, are completely determined by the choice you made. So for instance, take a look at all of these. Now you see the same angle, like this small angle over here is repeated right there and right there, for instance. If you pick this length right here, the other two sides are completely determined. You don't get to pick those numbers. You'd have to find them. You'd have to discover them. And same thing over here, right? So you can imagine taking this triangle and running it through a copy machine, just scaling this thing and it's bigger, and then this triangle gets bigger and so on. So you only pick one side and the other sides are completely decided. And one of the tools that you have to decide is, of course, the Pythagorean theorem. So if you have a right triangle, these are not examples of right triangles, but if you have a triangle with a right angle, certified right angle somewhere, then you get to use this theorem. It says that if you know two of the sides, you can find the third side using a little bit of algebra. So that's the basic thing that we'll need. Start with an equilateral triangle, and in an equilateral triangle, all of the angles are 60 degrees. And now we get to use that triple A principle. So the three angles are given, and you get to pick the length of just one side. You don't get to pick the length of all three sides. You can't pick different numbers. So let's just use the number 10 for this bottom side, for instance. And due to the fact that this is an equilateral triangle, what this forces is that these other sides are 10 as well. So the point is this. I didn't pick these numbers over here to be 10. I only picked this and then copied these numbers right here. All right, now the key thing that we're going to do, and the key ingenious idea, is to split this triangle into two pieces. So I've drawn a vertical line in blue right here that splits the triangle into two. And this blue splitting line is actually going to do a lot of great things for us. One thing it does is it's going to cut this angle right here into two equal-sized pieces. So those are two equal-sized 30-degree angles. Another thing that this splitting line does is, see this edge down here, it's going to cut this bottom edge, which was length 10, into two equal-sized pieces. So those two equal-sized pieces have to be length 5 each. And the final nice thing it ends up doing, it has a happy coincidence of creating this 90-degree angle right there. So now the thing to really look at or to focus on is this right half of this thing, or the left half, but we'll just look at this right half right here. This shaded in orange part happens to be a triangle whose angles are 30 degrees, 60 degrees, and this 90 degree that we just saw. So let's draw a copy of this. All I've done in the computer is just taken this thing, traced over, and just placed a copy of it right here. All right, now what I want to do is label some things that we've discovered from over here, over on the right. So first let's copy over these angles, this 30 degrees, 60 degrees, and 90 degrees. We'll just copy those angles over there. Then let's copy this, there was this 10 that we copied over here. We're just going to copy this length 10, that's this side right here. Notice where it is over on the right, it's this length right over here. We're going to just label that with a 10. And then what else? Well, this side of the triangle, this bottom side of this 30, 60, 90 triangle. This bottom side is right there. That's 5. So we're just copying this 5, just copied this 5. Not this 5, but this 5 was copied right over here. And that's all we get to copy. The length of this blue line is actually this right here, which we don't have. Now here's one other key thing to point out. If you really think of just starting with this triangle, we did not pick both the numbers 10 and 5. That's not what happened here. What we did was we picked the number 10 down here. That was copied over here, and that's what determined this 10. In essence, you could say in this triangle, we picked this side to be 10, and then we had to compute that this side was 5. Right? The point is that this 5 was exactly copied from over here, and this was 5 because it was, well, 5 plus this other 5 giving you 10. So these 5 and 10 are related, but we didn't pick both of these numbers. Started with the 10 and then the 5 popped out of it. Label the missing side with an h, and since you have a right triangle, you get to use the Pythagorean theorem. H squared plus 5 squared is equal to 10 squared, and if you solve, you'll get that h is equal to 5 times the square root of 3. We'll do the same experiment again, just a little bit faster. Start with an equilateral triangle. Now we're going to pick the side lengths to be 2. So you pick one side to be 2, the others are copied to be 2. There's a splitting line down the side. Get this 30-degree angle. Again, this side down here is split into two equal sized pieces of then 1, and again there was this right angle created right there. Notice the same right triangle, we'll copy it over to the side. This right triangle you see is actually a smaller copy of the triangle that we saw on the previous slide, right? I mean, now the angles are all the same, but now this is this sort of, think of the previous triangle we saw scaled down in a copy machine. Copy over this side, which is 2 from right there. Copy this side to be length 1. This last side is the mystery side, but we'll label it with an h so that we can solve for it using the Pythagorean theorem. H squared plus 1 squared is equal to, here's the hypotenuse side, 2 squared. Okay, and if you solve, you'll get that h is equal to square root 3. One last time, start with an equilateral triangle. This is a different equilateral triangle because now we're picking the length 7, so copy the length 7 all the way around. All 3 sides are length 7. There's a splitting line down the side, cuts that top angle into 2 small pieces of 30 degrees. The bottom side length here, now you have 2 equal sized pieces which are half of 7, so this is 7 divided by 2. It's not a really nice looking number, but that's because 7 was odd. Moral of the story here, you can use an odd number, but the math will work out a little nicer by using an even number as the number to pick. Okay, so you have the side length of 7 divided by 2. There's this 90-degree angle again. Take this right triangle, make a copy of onto the side. Copy the 3 angles over again. Copy over this length 7. This 7 copied this number here, not these other 2. This side length right here, this 7 over 2 was copied from right here, not right there. And then, again, we don't get to pick this. All we've done is we've really picked this number and derived this number. And since you have 2 sides, use that principle of a right triangle, label the third side with an h, and then set up the Pythagorean theorem, solve for h, and you should get that h is equal to 7 over 2 times square root of 3. Okay, now it's your turn. What you should really do is try the same experiment with different numbers. The whole point is that you only get to pick one number. So we picked this number 7 down here. Earlier we had picked a 2. Even before that we had picked a 10. But you could pick any positive number to use right there. And then the point is that number gets copied right there and right there. And in turn, from copying, that number ends up right there. Then what happens is, due to the splitting line, this 7 over 2, so half of whatever number you picked ends up right over here. And then the whole point is that this third side is found using the Pythagorean theorem, right? You'll know these two, and you get the third side using the Pythagorean theorem. Now that you have all 3 sides labeled in a 30, 60, 90-degree triangle, in a right triangle, you can now compute sines and cosines and so on.